Hi, good morning everyone. How are you guys? Am I audible and visible to you? Shillong, are you there? Hey Shillong, am I audible and visible to you? Please confirm once as well as share your attendance. Can I have one person on the system at the center so he or she can reply to me so that we can start? Shillong, wave once in front of camera if I am audible to you. Wave in front of a camera. Okay. Dear, please share your attendance and tell me how was your exam? How was your exam? Okay. Very good. So guys, tell me what topic are we discussing in the previous class? So that we can proceed. N plus L rule. Okay. So please tell me, is there any confusion regarding that? Was it clear to everybody? Okay. Tell me, which one will have the higher energy? Question is, which one will have higher energy? Hmm. 4D versus 6S. Tell me, which one will have the higher energy? Okay, how many of you has got 6S as the answer? Please raise your hand. Those who has got 6S as the answer. Okay, very good. Okay, nice. Yeah, absolutely 6S will have the higher energy. Do we have discussed the electronic configuration? Do we have discussed the electronic configuration? Okay, so let's begin with the electronic configuration. Okay, hi everyone. You all are just, guys, are you feeling sleepy? Okay. So guys, let's begin. Please do not copy. Just make sure that the topic I'm covering, it should be clear to you. Okay. So first of all, look at the screen. Try to understand the concept. After that, I'll give you time to copy that. Okay. So I think we have discussed about the obverse principle. Okay. In the filling of atomic orbitals, that rule will be dominating. We have to fill the atomic orbitals on the basis of that rule. But other than that, we should have knowledge about these two rules as well. That Pauli's exclusion principle. Pauli's exclusion principle. It says that no two electrons in an atom can have same set of 4 quantum numbers. Okay. Let me take an example. I'll clear it to you. Guys, let's consider the 3s. Okay. If I talk you about the 3s, n will be 3, l will be 0. If I talk about m, that will be 0. This is not a mathematical 0, guys. This is the designation. I have already covered this. If I talk about the s, which is the spin quantum number, it will be either plus half or minus half. Because we know that when we talk about the s subshell, we will have 2 electrons in that. Okay. So guys, what can we conclude? That we can have n equal to 3, l equal to 0, m equal to 0. In one case, s can be plus 1 by 2. Whereas in the second case, s can be minus half. It means that when we talk about a orbital can maximum have 2 electrons. One orbital can have maximum of 2 electrons. So guys, if in any case 3 quantum numbers are same, if I talk about the 3s, see, these 3 quantum numbers are exactly same, but if I talk about the s, that will be definitely different. Okay. So 1 electron means that in atomic orbital, the electrons, the number of electrons that we fill will definitely have a spin quantum number different whenever we talk about the 2 electrons in an orbital. Okay. So this is what the Pauli's exclusion principle says. Okay. Whenever we talk about atomic orbitals, 3 quantum numbers can be same, but 4th one will always be different. Okay. Guys, remember, I'm talking about the 2 electrons. Okay. One orbital can have the 2 electrons, so fourth atom quantum number will be definitely different. Okay. So if I talk about the statement will be this one. No 2 electron in an atom can have same set of 4 quantum numbers. Guys, is it clear to you? Is this explanation clear to you? Do you need some more explanation on this one? You have to just focus that whenever we talk about the atomic orbitals in an atom, 4 quantum numbers can never be same. Spin will always be different. Okay? Any doubt in this one? Is it clear to you? Okay. So those who are sitting like this and who are thinking like this, can please copy this. Or first of all, guys, please copy this statement, and after that example. Start. Oh, hi, Itanagar. Now you can copy this one. The student who is sitting at the first bench on my right hand side, dear, have you copied that? Oh, okay. I'm not getting you, Itanagar. Means your electricity means. Okay, is there electricity problem over there? Okay, that's cool. So guys, this was the Pauli's exclusion principle. Now the next rule is, good. Now the next rule is Hund's rule. Okay, Hund said a simple thing. I'll write its statement later on. First of all, let's clear the concept. See, let's say suppose I have nitrogen whose atomic number is 7. Okay. Its configuration will be 1s2, 2s2, 2p3. Guys, relax. I'll discuss how to write the electronic configurations. Okay. So guys, let's talk about the 2p. We know that p subshell has 3 orbitals. Okay. The power 3 represents number of electrons. The power 3 represents the number of electrons. So, how we can fill these 3 electrons in this particular orbital? See, I can fill it like this: upward arrow, downward arrow, upward arrow. This is one of the method. Please do not copy this, guys. Do not copy this. Then, I can have this method as well. I can fill in this manner as well. One second. I can fill in this manner as well. Okay. I can fill in this manner as well. I can fill in this manner as well. Okay. I can fill in one second. this manner as well. So guys, there can be n number of methods or ways to fill these electrons. Okay. So this is not universal actually. If I say I'll fill according to the first box, this is my rule. But some of you will say that no sir, we will fill according to the second one. Then some of you will say no sir, last one is looking little bit cool, so I'll use that one. Okay. So this is not universal. Okay. This is not correct way to fill all of these. So if I talk about all the methods are wrong. Okay. While filling the atomic orbitals, all the methods are wrong. So Hund explained that we have to follow a particular situation, particular rule while filling the atomic orbitals, and that will be true for every atomic, every element. Okay. Hund said that. See, I'm still talking about the 2p3. Hund said that first of all, we will fill the orbitals with the single electron having the same spin. So 1, 2, 3. See, I have to fill only 3 electrons. That's why I'll stop it over here. So this is the absolutely right way. Okay. But let's say suppose I have got 2p4. What will I do? How can I fill it? Again, you will do the same. First, you will singly fill every atomic orbital, and then pairing start, because we know that one orbital can accommodate 2 electrons. Guys, here single box represents one orbital. Okay. Then you will go back to the 1 and you will fill the one more electron, but remember the spin should be opposite. Okay. To gain the maximum stability. So here you can fill like this. Let's say suppose you have got 2p5. How can you fill that? 1, 2, 3, 4 and then 5. Okay. If we suppose we have 3d7, we know that d subshell has the 5 orbitals. Okay. So how we will fill these 7 electrons? 1, 2, 3, 4, 5, back to 1, 6, 7. This is your Hund's rule. Okay. It says that while filling the atomic orbitals of having the same energy, guys, these 3 boxes, when I talk about the p orbital, all of them has the same energy. If I talk about the d's, a d orbital, so these 5 d orbitals has the similar energy. Okay. So it says that first you will fill the electrons singly. Okay. Means atomic orbital first will be filled singly. Then pairing will start. After the accommodation of single electron in every orbital, you can start the pairing. Before that, you cannot start the pairing. Okay. Pairing can start only when you will fill every orbital half filled. Okay. If every orbital is accommodated 1 electron, then you can start pairing. This is the Hund's rule. Is it clear to you? If it is clear to you, then I can write statement for you. If not, you can tell me. Clear? Okay, good. So guys, I'm writing a statement for you. You can copy along with me. Okay. Oh, yeah, this one. Let's start. While filling atomic orbital having similar energy, first they filled, they are singly filled, and then pairing starts. copy and confirm me once. Can we move on? Okay, so let's start. Now, electronic configuration. Okay, guys, look at the screen. Let's start with the hydrogen, atomic number 1. Guys, for that you have to remember the obverse rule that first of all, you can refer that one. First orbital is 1s, then 2s, 2p, 3s, 3p, 4s, 3d, 4b, and so on. Okay, up to 4p at least you have to remember. So first is s. Other than that, you should remember that s can accommodate maximum of 2 electron, p can accommodate 6 electron, d can 10, and f can accommodate maximum of 14 electrons. Okay. So guys, H, atomic number 1, it means that 1 electron is there. So you will write 1 over here. The power represents the number of electrons. Next is helium, atomic number 2. So I can write it 1s2. Okay. Lithium, atomic number 3. You will say 1s2. Okay. You have to fill the 3 electrons, out of which 2 has been filled in s atomic orbital, because s can have only maximum 2 electrons. So we have to go to the next orbital. After 1s, we have got 2s. Okay, we have to fill 1 electron over there. So this will be what? 1s2, 2s1. Beryllium, 4. 1s2, 2s2. Boron, 5. 1s2, 2s2, 2p, 1. Carbon, 6. 1s2, 2s2, 2p, 2. Copy. Copy please. Now, let's say suppose we have got fluorine, atomic number 9, 1s2, 2s2, 2p, 5, okay. Sum the electrons, 2 plus 2, 4 plus 5, 9, okay. This is how we write the electronic configurations. So guys, this is the question for you. Once again, we can do ionic species as well. See, let's say suppose we have got Na plus. We know that the atomic number of sodium is 11. Okay, Tanagar, do it quickly. Can we move on? Okay. Let's discuss about the Na plus. Atomic number is 11. Guys, plus means loss of electrons and minus means gain of electron. So actually, out of 11, one electron has been lost. So we are actually left with only 10 electrons. So while writing the electronic configuration, we have to fill only 10. So it will be 1s2, 2s2, 2p6. Clear? Let's talk about Cl minus. Chlorine is 17. So minus means gain of 1 electron. So 17 plus 1 is 18. So we have to fill 18 electrons. So it will be 1s2, 2s2, 2p6, 3s2, 3p6. Okay, is it clear to everyone? If I talk about Mg2 plus, magnesium is 12, means loss of 2 electrons. 2 plus means loss of 2 electrons. So this one will be 1s2, 2s2, 2p6. Any confusion or doubt regarding this one? Any confusion or doubt? Okay, copy please, and after copying, just confirm me once, then after that I'll give you few questions on this one. Copied? So guys, this is the not homework, questions for you. You have to write the electronic configurations. Just attempt the questions and then confirm me once that you have attempted all the questions, and then I'll write the electronic configuration. You have to just confirm. Okay, just cross check. Scandium 21, manganese 25, manganese 25, Fe2 plus, atomic number is 26, then cobalt 3 plus, atomic number 27. Please attempt these questions. Okay. Two more minutes. Guys, you can refer the Aufbau's principle. Okay. You can follow that sequence 1s2, 2s2, and so on. Start. Can we start, guys? Okay, let's start. This is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. How many of you has got these four answers? How many of you has got these four answers? Shillong, due to network issue, I cannot see that how many of you are raising your hand. Okay, 10 has got this answer. And how many of you haven't got these answers? Okay. So, my dear students, first of all, this is correct, this is correct. F is wrong, cobalt is also wrong. Oh, Fe2 plus and CO3 plus are wrong. Okay. Those who have written electron configuration like this. Now let me clear. Please tell me one thing. This is your atom. This is your 3D. This is your 4s. 4s has got 2 electrons. And 3D, we don't care about it. How many electrons 3D have? Okay. Let's consider 3D as only 1 electron. First of all, tell me, whenever electron will be released from an atom, from which orbital it will release? From 4s or 3D? If I say we have to remove 2 electrons, which orbital will release its electron? 4s or 3D? Good, 4s. So guys, in the configuration, Aufbauer's rule says that 4s has the lower energy, that's why it is filled first. But guys, 4s is the outer orbital, whereas 3D is the inner orbital. Okay, so electrons will be released from the 4s, not from the 3D. Okay, so when we will talk about the Fe2 plus 1s2, I am writing the configuration for the Fe only. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. This is for the Fe. Now we have to remove 2 electrons. So obviously we won't remove those 2 electrons from the 3D. We will remove those electrons from the 4s. So actually the configuration should be this one. 1s2, 2s2, 2p6, 3s2, 3p6, 3d6. Are you getting the concept? Are you getting the concept? Any confusion regarding this one? Now you can change for the cobalt as well. Guys, is there any confusion regarding this one? What confusion? Please copy and correct cobalt as well. Done? Okay. So guys, exactly same configuration will be for cobalt 3 plus. Okay, same configuration. So guys, please remember this one. Okay, quite important. Now, let's discuss about the exceptions. First is chromium, atomic number is 24. If I write, and guys remember this is for the ionic configurations, means this is for the ionic compounds, okay. Now, let's start with the chromium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. Guys, stability rule says that if by shifting of one electron, okay, by shifting of one electron, if both the orbitals either become the exactly half filled or become the fully filled, okay, D has the higher energy. D has the higher energy, okay. If D has got exactly half filled electronic configuration or fully filled configuration, the stability relatively more, okay. So what happened here, that one electron of 4s will shift from here to the 3D. One electron will shift to the 3D. Now the configuration will become what? 4s1, 3d5. This is the stable configuration. Inner core configuration will be exactly same. No changes in that. Only 4s2 3d4 will become the 4s1 3d5. Okay, so this is the exception that you have to remember, that here we will shift one electron, and after shifting of one electron, they both will become the exactly half filled, which is extra stable half filled configuration, which has the higher energy, which has the higher stability. That's why we will write this one, extra stable half filled configuration. Please copy. Any confusion or doubt? Okay, so let's move on to the next exception, which is copper. 29. See, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. Again, by shifting of one electron from here to here, 4s will become the half filled and 3d will become the fully filled. Again, this is a relatively more stable configuration if I compare with respect to the 4s2 and 3d9. Okay, if I compare 4s2 3d9 with 4s1 3d10, so this one is more stable. This one is more stable. That's why we will write this one. Okay, these two exceptions you have to remember, which are important with in reference to your examinations. Okay, please copy this. Please copy this. Copied? The next question, write the configuration for the atomic number 117. Guys, I'm writing this configuration, okay? You have to remember this one, and if you remember this one, all the elements which are nearby the 117 are very easy to deal with them, okay? See, for the atomic number 117, you can remember this configuration. Radon, which is 86, okay? Core configuration will not be changed, so I can write it like this, okay? This is the noble gas configuration. Then 5f14, 6d10, 7s2, 7p5. Guys, you can count total there are 117 electrons. 86 plus 14 is 100, plus 10 110, plus 7 is 17. You can remember this one. Okay. Suppose you have to write the electronic configuration for 113. It means that from 117 you have to remove 4 electrons. So obviously you will remove the 4 electrons from the outermost orbital. Okay. So for the atomic number 113, the configuration will be what? Radon 86, 5f14, 6d10, 7s2, 7p1. Okay. So you can write in the same manner for the atomic number 100, above atomic number 100. You can write the configurations for them easily. Any doubt? Any doubt? Do you need some more explanation? Okay. Hi Tamelong. Okay, if you have copied that, write the electronic configuration for atomic number 110. Write the electronic configuration for 110. After attempting that question, just confirm once. Okay, let's see. Will it be look like this? 5F14, 6G10. Is it right? How many of you has written electronic configuration like this? Okay, very good. This time everyone is right. Okay, this is the configuration for this one. Okay. So guys, that's all about the electronic configurations. You can write the electronic configuration like this. Okay. Now, if I say there is another question in Z equal to 19, how many electron can have same spin? Guys, copy this question. Copy this question. I'll give you few hint. Okay, how to attempt these kind of questions. See, if I say beryllium, atomic number 4, so you can write 1s2 and 2s2. This is your s orbital, this is your s orbital. So you can write electrons like this. So question says that how many electrons can have the same spin. So guys, either you can choose the electrons which are pointing upwards, or you can choose the electrons which are pointing downwards. So if I choose the electrons which are pointing upwards, you can find only 2 electrons are there. If you choose the electron which are pointing downwards, so again there will be 2 electrons. Okay. So if the question is same as like previous one, so answer would be what? 2 electrons. Are you getting this? Then the answer will be what? 2 electrons. So in the same manner you have to attempt that question. Please do this question. Any confusion? Okay. Who has got this answer? Okay. Anyone else? Hi, Paul. Next answer, please. Oh, hi, Annie. Hi, Kane. Have you got the same answer? Hi, Daisy. Hi, Shem. You all are getting the same answer. I haven't said this is the wrong answer. Okay, I'm just saying hi. Okay. Anyone else who needs some more time? Or can I start? Itanagar Tamelong, guys. What's your answer? Can we start, guys? Is there anyone who has got some other different answer? Okay, question was the same spin. You can choose either negative or positive, doesn't matter. It means answer has changed. If you're saying 10. Spin is not mentioned over here, so you need not to worry about the spin. You can choose any, either positive or negative. You have to tell me how many electrons can have the same spin. Okay, who has got this answer? 10 have the positive spin, 9 has the negative spin. Who has got this answer? Hi, Varni. Guys, let's begin. Let's begin. See, I'm writing the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Okay, this is the electronic configuration. Okay. So you can consider either positive or negative. So take a look. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. 1 second. Let me make it a little bit clear. 1, 2, 1, 2, 1 and 2, 1, 2, 1, 2, 1, 2, 1, 2, and then, okay, oh, this is 1. So, I said you can choose either positive or negative. So, see, if I choose the electrons which are pointing upwards, so I can have 1 from here, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So, this is the maximum possibility. Maximum we can have the 10 electrons. Maximum we can have the 10 electrons which has the same spin. If I talk about the minimum, so obviously the rest will be what represent the minimum one. So minimum we can have 9 electrons. Other than Varni, is there anyone who has got this answer? Any confusion or doubt regarding this one? Any confusion or doubt? Hi, Ampli. Anybody wants to ask me anything? And what about other students? What are they doing? Are they enjoying their breakfast? Or they are busy with the Google or YouTube? And the rest? Okay. So guys, this is the question. I want everyone's name on the screen. Okay. I mean, everyone has to solve this question. What about you, Itanagar and Tamelong? Question is, how many electrons will have the same spin? This time atomic number is 24. Do this question. Atomic number 24. How many electrons will have the same spin? Itanagar, Tamelong, guys, are you there? Is there network issue? Or you become the passive? Okay, very good. Who has got this answer? This might be the right answer and might be the wrong. If all of you has got the same answer, you can simply write the all. No need to write the names. If everyone has got this answer. Okay, that's very good. So guys, let's solve this question. Let's see. It is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. This is the chromium, na? 4s1, 3d5. Okay. So 1 from here, 2, and then 3 from here, 5, 6, 9, and 6, 15. Very good. So 15 max and 9 minimum. Very good, guys. Nice attempt. Okay. So guys, let's take a 5 minutes of break and I'll see you in 5 minutes. Okay. Hi guys, back again. So guys, are you there? Can we start again? Hi. Confirm once guys. Hello everyone, am I audible to you? Break is over guys. Shillong, Tamelong, Itanagar. Hi Tamelong. Shillong, due to the network issue, there is a hang at the system, so I cannot see you clearly. Okay, if you are taking some actions as well over there, so please reply on the screen. Okay, hi. Okay, so guys, okay, your S is actually shifted to the sir, so it becomes a ye sir. We can hear you. That's new actually. Okay, leave that. So guys, I hope so it is clear to everyone. Now the next topic is the node. Sorry, node. Okay. So guys, we have discussed about the orbital. Orbital is the region where probability of finding the electron is maximum. Obviously, there will be some region where you won't get any electron. So the region around the nucleus where you won't get any electron is known as the node. Is it clear to everyone? That region around the nucleus where you won't get any electron is known as what? Node. Okay. So guys, we can write this one first, that the region around the nucleus in an atom where probability of finding electron is 0. We can say psi square will be 0. Guys, psi square means what? Psi square is an orbital wave function which represents the region where we can get the electrons. Okay? If you talk about the psi square, this is your orbital wave function. Represents probability density of electron. Ultimately, psi square means it will represent that region where we can get the electrons. Okay? If psi square is 0, it means that we won't get any electron. Please copy this. And after copying, confirm once. Done. Okay, let's move on. Guys, there is a one more point which is known as the nodal plane. I hope so. You know about the plane. Plane means XY plane, YZ plane, XZ planes. Okay. When we talk about the axis, okay. So in the axis, we have the X, Y and Z axis. Okay. So if I take the XY axis simultaneously, means if I talk about the XY, look at this one, please. This is X, this is Y, and this is Z. So guys, this is your XY. Okay, so this is your XY plane. See, this is your XY plane, this is your XZ plane, and this is your YZ plane. Okay, so guys, obviously the node will be present in any one of the plane, means node can present in any of these planes. So we can say the plane containing the node will be known as what? Nodal plane. Okay, the plane containing the node will be what? Nodal plane. Again, you can say in this plane we won't get any electrons. Okay, so node containing plane. No, you can write like this. A plane in which sine square is 0. Okay? A plane in which sine square is 0. This is a nodal plane. Now we have types of nodes. Types of nodes. First is your spherical. The formula to calculate the spherical node. If I talk about the spherical nodes, means these are spherical in shape. Ultimately, the name has been derived on the basis of their shapes. Because these are spherical in nature, that's why they are termed as the spherical nodes. The formula is n minus L minus 1. Second is your angular. Means they will be inclined at some angle. If I talk about the with reference to the standard set of coordinate axes. Okay, and this one is represented by the L. Now, total nodes. That will be spherical plus angular. So, I will simply sum up. On solving, I'll get n minus 1. Okay. So, guys, here the important part is we have to remember these formulas. Please copy. Guys, the names has been derived on the basis of their shapes. Okay, these are known as the spherical because these are spherical in shapes. Okay, please copy and then let's explore something little bit more regarding the nodes. Copied. Okay. Guys, see. Orbitals N, L, radial node, angular node, and this is your total node. Okay, 1 second. Orbitals N, L, radial node, angular node, then total node. Radial node or spherical node has the same meaning. Okay, radial node and the spherical node has the same meaning. This is your n minus L minus 1. This is your L, and this is your n minus 1. Okay, so guys, look at this. If I say 1s, so n will be 1, L will be 0. Radial node will be what? You will put the value of n and L and you will get your answer. N is 1, L is 0. On solving, it will be 0. Angular node represents L, which is 0. So total node will be how much? 0. There is no node in 1s. 2s, n will be 2, l will be 0. Radial node will be 1, angular node will be 0, and total node will be what? 1. 2p, 2, 1. So if I put these values over here, I'll get radial node 0, angular node 1, and total node 1. So guys, what do we have to learn over here? That in case of 2p, we will have a total node of 1, and that node is actually angular node. There is no spherical nodes. Okay. If I talk about 3s, see, 3, 0, this is your 2, angular node 0, and this is your 2. So guys, by these formulas, we can get these values. In case of 3s, we have 2 nodes in total, and both of the nodes are radial in nature. There is no angular node over there. Okay. Please do this one, 3p. 3p. Please write the radial node, angular node, and the total node, and reply on the screen. Okay, please do not reply on the screen. Just attempt this. After that, I'll write the answer for you, and you have to just cross-check. Done? Is everyone has attempted that question? Okay, so let's see. 3, 1, 1, 1, and total 2. In case of 3p, we will have 2 nodes. In total, one will be radial and another one will be angular. How many of you has got the correct answer? Shillong can raise their hand in front of camera. Okay, good Tamalong. No connection. Okay, so guys, let's start. Now guys, look at this very carefully. I'm drawing 1s. 1s will be look like this. That just after the nucleus, just outside the nucleus, we will get the electrons. This is 1s. So obviously just after the nucleus we are getting the electron, so there is no angular node. Sorry, there is no node over there. Okay. So in the 1s we have seen that there is no node. Okay. If I draw 2s, guys look at this. In 2s, just after the nucleus there will be a region where I can get the electrons. Now, between this region and the next one, there is a space. There is a space when you will write the 1s. Sorry, when you write the 2s. Guys, look at this. The inner region was the 1s, because we know that in case of 2s, one orbital will definitely be involved inside. So guys, you can observe this one, that there is a region which is empty over there and which represents a node. This is your node section. This is for the 2s. Okay. If I draw for the 3s, just after the nucleus, I might get the electron. After that, there will be some space. After that, where we can get the electrons. After that, again there will be some space. See? Now you can look at this one. This is node and this is also node. So this is for the 3s. 3s got the two nodes. Please copy. And any confusion or doubt regarding this one? Is it clear to everybody? Is it clear to everyone? Okay. If anyone has doubt, please you can ask me. If not, then we can move on. Just copy this and confirm me. Okay. Guys, you have to remember these graphs as well. First of all, look at the screen. This is for 1s. R is the internuclear distance, means distance from the nucleus, and this is psi. Psi is the orbital wave function. Or dear, those are not important, that's why I haven't drawn that one for. Okay, and that was just for concept clarification, that how we are getting the nodes. Okay. So guys, this is the psi versus r. Psi is the orbital wave functions. Now, for 1s, if you talk about the 1s, this graph actually looks like this. Okay. If we talk about, guys, do one thing, please, draw it in the same manner which is I am drawing for you. Okay. This is for the 2s. This is for 2s. It look like this. This is for 2s. This is R. Guys, this is your positive phase. And this is your negative phase. The point where it is intersecting the axis is your node. See, in 1s there is no intersection, means no node. In the 2s it is intersecting at one point, that's why it has got the one node. Now, (2p), the graph will look like this. Okay, positive, negative, positive. Guys, again I am repeating this, the orbital wave functions, you have to remember these. Okay, quite important for the examinations point of view. Now, if I point out the nodes, see, it is intersecting at the 2 points, and these points are nodes. Okay? I have to draw one more. Guys, you will draw the fourth one exactly next to the 2p. Okay, here I haven't got the space, that's why I'm drawing behind it. I mean below it. So you will please draw, sorry, one thing, this is not 2p, this is your 3s. This is your 3s. I'll draw 2p right now. This is your 2p. This is r. This is sine. So 2p look like this. Okay, this is your 2p. Please copy, and after copying that, confirm. Okay. Now guys, please confirm me one thing, that if I say y is equals to minus x, okay, then what will be the value of y square? If I say y equal to minus x, then what will be the value of y square? You can take this example as well. Y equal to x, then y square. Okay, in this case, this will be x. And what about in this case, where it is already positive? What about this one? Okay, this is the square as well, dear. Will this one will also be x square? Can we say that? That if I square negative value or the positive value, result will always be positive. Is it clear to everyone? If I square a negative value, it will always result into a positive value. Okay? So guys, now look at this. I am drawing the graph for the x square. Sorry, sine square. This is your sine square. Okay? So guys, obviously, if I square, then there will be no change in the graph, because that was already positive. That was already positive. So for the 1s, there is no change. But for the 2s, the negative phase will become the positive phase. That will be only change. Okay? That the positive phase will become the negative phase. So I'll remove this one. Oh, 1 second. See? This was your node. That section will come in the upper side. Now it will become positive. That will be the only change. If I square this one, what will happen? Again, the positive phase will remain the positive, but the negative phase will become the positive phase. That will be only change. So guys, look at this. Please, you have to draw all these shapes again. You have to draw all these shapes again. See, again you find the two nodes. Again, in case of 2p, there is no change. It will remain the positive. Understood? Clear? Any confusion or doubt? Hey guys, is it clear to you? Do you have any confusion or doubt? You want to ask me? You're most welcome. You can ask me. Okay, please copy. Draw it again by putting the sine square. Okay. Tamelong, Itanagar, guys, have you copied that? Okay. Guys, do we have discussed this one? Orbital angular momentum. Angular momentum is equals to under the root L into L plus 1 h upon 2 pi. H upon 2 pi can also be written like this. Okay. So this formula will become this one, L into L plus 1 H. Do we have discussed this formula? If not, then copy this. Copy, please. Okay, please copy. Okay, so guys, let's move on. See, orbital, I'm calculating the orbital angular momentum for 1s, 2s, 3s, and so on. See, orbital angular momentum depends on the L. Okay, so if I use 1s, 2s, 3s, okay, principal quantum number won't affect the orbital angular momentum. So in this case, we know that value of L equal to 0, then orbital angular momentum will be what? 0 into 0 plus 1 into h upon 2 pi. Okay, this whole value will become 0, so orbital angular momentum will be what? 0. Okay, first case, second, 2p, 3p, 4p, and so on. For this one, value of L is equals to 1, and if I calculate orbital angular momentum, you have to put this formula, or sorry, you have to put this value in the formula. This one will be 1 into 1 plus 1 into h upon 2 pi. So this is on solving will become under the root h upon 2 pi. Okay, this is your h upon 2 pi. Similarly, guys, you can calculate for the 3D, 4D, 5D, 4F, 5F. Okay, please copy this and do that one. Copy this and do it for the d orbital as well and f orbital as well. After that, I'll solve it for you. You have to just cross check. And guys, please tell me, have you solved the previous year's NEET questions, NEET and AIMS questions of redox reactions after solving that assignment? Have you solved all the NEET and AIMS questions previous years of redox reactions? Is there any confusion or doubt in the NEET and AIMS questions of redox reactions? Guys, let's do it for this one. Number 3, 3D, 4D, 5D. Here value of L will be 2. Orbital angular momentum will be 2 into 2 plus 1 h upon 2 pi. So this is your under the root 6 h upon 2 pi. Fourth, 4f, 5f and so on. L will be 3. Orbital angular momentum will be under the root 3 into 3 plus 2. Sorry, 3 plus 1. H upon 2 pi. On solving, we will get 4 3s are 12. So we can take 2 out of the root, h upon 2 pi. On further solving, it will be root 3 h upon pi. Please copy those who haven't attempted these remaining 2 atomic orbitals. Please copy. Guys, please confirm me once, is there any confusion or doubt regarding this one? Any query? Anything that you want to ask me? Okay. Shillong. Any confusion or doubt? Okay. Excuse me. So guys, finally we have ended up the structure of atom. Okay, the whole chapter is over. I'll provide you assignment of this one and I'll give you 1 week of time to solve that, and after that we will have a doubt class. Okay. Now the next thing, please attempt this question. Calculate number of unpaired electron. Number of unpaired electron in boron and manganese. Guys, I'm doing this question, boron, I'm doing boron for you. Please look at this. Atomic number 5. Configuration is 1s2, 2s2, 2p1. Okay. So guys, if you look at this one, 1s2 orbital, see, one orbital can accommodate maximum of 2 electrons. If it is filled, if both the electrons are present over there, it means it is fully filled, no unpaired electrons. If I talk about the 2s2, again it is a paired. If I talk about 2p1, so in 2p1, in one atomic orbital, which is this one, in one atomic orbital there is only one electron. Okay, that's why I'll say this is what? Unpaired electron. So in boron there is one unpaired electron. Any confusion or doubt? Please do it for the manganese. Atomic number of manganese is 25. Determine the number of unpaired electrons. Do that. Do it for the manganese. Any confusion regarding this one? And tell me the answer, how many unpaired electrons will be present in the manganese? Done. Can I start? Okay, let's start. Atomic number 25. Configuration will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. So all the orbitals are fully filled except 3d, 5. Okay. So there are 5 unpaired electrons. Okay. So I have got your answer as well. So congratulations to all of those who has got the right answer. This is high five to all of you who has got the right answer. Now the next question. Again you have to calculate the number of unpaired electron. Atomic number 24. Please calculate number of unpaired electron and write your name as well. The student who has got the answer first will write its answer along with its name. Please start. Every center, Shillong, Tamelong, Itanagar. I'm waiting for the answer. Please do it. Who has got this answer? If all of you has got the same answer, you can simply write all. If not, then you have to mention yourself. Okay, that's cool. So guys, it is nothing else but the chromium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. Very good. 6 electrons. Nice. Okay. Now, cobalt 3 plus. Number of unpaired electrons in cobalt 3 plus. Atomic number is 27. Z is 27. Number of unpaired electrons in cobalt 3 plus. Okay, who has got this answer? Okay, I think all of you has got the same answer. Can we start? Good. 1s2, 2s2, 2p6, 3s2, 3p6, 4s0, 3d6. So in case of 3d6, it will look like this. 1, 2, 1, 1, 1 and 1. So you can see there are 4 electrons. Very, very good. Those who has got the right answer, and those who haven't, please copy. Okay. Next question for you. A neutral atom of an element has 2k, 8l, 11m and 2n electrons. The number of p electrons in the atom are option A 2, 7, wait, not 7, 12, 10 and 6. Do this question. Do this question, tell me the answer. Okay, very good. Who has got this answer? If all of you has got the same answer, you can write all. If not, then please you can mention yourself. Okay, Annie has got this answer. Anyone else? Oh, Nisha has also got this answer. Varni has also got this answer. Hi to everyone. Can anyone please write in short that how you attempted this question? Oh, hi Nitish, hi Paul. Hi. Can you please write in short that how you have attempted that question? Anyone? Or should I start? Okay, by adding electrons of the all shells, we got 23, very good. And then we have to simply write the electronic configuration. We'll get our answer as a 12. Yeah, absolutely fine. Yeah, very good. Guys, these K, L, M, N are actually shells, nothing else. Okay, you can sum up, and these are representing the electrons: 2 electrons, 8 electrons, 11 electrons, and then 2 electrons. Okay, so you can sum up all these, and you will get the 23, and you can write the configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 3. They are asking for the p electrons. So guys, you can figure out this is the p, and there are total 12 electrons. So option B would be the right answer. Got it? Okay, so is there any confusion or doubt? Guys, that's all about the structure of atom. We have winded up. I'll share the assignment with you. Even at the last time I told you that please remind me once, and unfortunately I forgot that, and no one from you has reminded me that we need assignment. Okay, but I have make note of this one right now, so I'll share it by the evening today, or most probably in the next 1 or 2 hours. And after that, I'll give you 1 week to solve that assignment, and after that, we will have a doubt class. And in the next class, we are going to start the chemical bonding, the new chapter, okay? And we'll proceed with that, okay? And in the first half, if anyone has got any confusion or doubt in the structure of atom, please go through the whole notes once. And if you find any confusion or doubt regarding any concept, please you can ask me in the beginning of the class, okay? So guys, till then, take care, bye-bye, have a great time, take care of yourself, stay healthy, see you next time.